Okay.
Okay. So let's start with your questions. Let's go towards the question set. Okay, P1 is P1. Okay. Okay, so let's start with the topical first paper session. We are starting with P1, right? And this is the first question in your question set. So you have a measuring cylinder, which is basically used to measure the volume of a stone. And initially, without any stone some immersed in the liquid, we had volume V1 that was given to you as 20 centimeter cube, right? You can see it over here. And then after immersing the stone inside the liquid, the volume is V2, that is 38 centimeter cube, right? So now they are saying that what is the volume of the stone, right? We have done this in our lecture set, so it is pretty simple here. So if you want to find the volume of stone, so the volume of stone is going to be the volume of water plus stone, that is V2, minus the volume of water only, right? So it's going to be 38 minus 20. So the volume is coming out to be 18 centimeter cube, right? So the answer is option number A. Is that your answer?
Yeah.
Okay, good. Let's go on towards question number two. Okay, so the question number two is upon the gravitational field strength and your mass, right? So you can have mix up questions which are going to test your prior knowledge. So we had covered mass and weight before, right? So it should not be difficult to solve this question here, right? So let's start. So they're saying that the weight of a cylinder on the moon is less than the weight on the earth here, right? So what is the reason that causes this change here, right? So how do the gravitational field strength of and the mass of cylinder compare to when you place it on the moon and then if you place it on the earth, right? So if you know the numerical values, it's going to be pretty easy, right? Otherwise it's going to be pretty simple also, right? So the gravitational field strength on moon is around 1.6 newton per kg, and the gravitational field strength on earth is, if you're taking IGCSE board, it is 9.8 newton per kg, right? So you can always compare that the gravitational field strength of the moon is going to be not same. So option A and B are wrong, right? It's not going to be zero here. So it's going to be less than as compared to the gravitational field strength of Earth, right? So your answer is option number C. And the mass do not change, it remains same throughout the universe. That is the conservation of mass law, right? So does that make sense?
Yeah.
Okay, so let's go on toward question number three. So question number three is stating again on weight and mass, right? So let's see what are they saying. Four rocks on different planets have masses and weight, which are shown here. Which planet has the greatest gravitational field strength, right? So for this, you have to recall your weight formula here. That weight is equals to mg. And how do you find gravitational field strength of a planet? That is the weight per unit mass, right? So you have the weight and you have the masses of the object at different planets, right? Simply you can find the weight over mass ratio of each option. The greatest mind is going to be the answer for your question number three, right? So this is going to be 14 upon 2. That is going to be 7 Newton per kg. And this is going to be 20 upon 2.5. And what is 20 upon 2.5? It's 8 Newton per kg. And what is 21 upon 3? It's again 7 Newton per kg. And then we have 19 upon 3.5. That is coming out to be 5.43 Newton per kg, right? So which planet has the greatest gravitational field strength? That is option number B. Make sense?
Yeah.
Okay, good. So let's go on towards the next question in the pipeline. That is question number 4. Okay, so what is question number 4 saying? So you have a stone that has a mass of 390 grams. It has a density of 2.7 gram per centimeter cube. Then you have cooking oil whose density is 0.9 gram per centimeter cube. Which mass of oil has the same volume as of the stone, right? So first of all, we can find out what from the data given to us. We can find the volume of stone from the data. The volume of stone, if you recall the formula of density, so density is mass per unit volume. If you want to make volume subject, that is going to be what? It is mass upon density, right? So from this, we can find out what? We can find out the volume of the stone, right? So the volume of stone is going to be 390 divided by density of the stone, 2.7, right? So let's see what do we get. So it's coming out to be 144.444 centimeter cube, right? Now you want the volume of what? You want the volume of cooking oil to be same as the volume of stone. We want the volume of cooking oil to be 144.44 centimeter cube. And you know the density of the cooking oil. So you can simply find out the mass of the cooking oil from the formula, right? So what is the formula of density? Density is mass per unit volume. If you want to make mass subject, the formula becomes it is density times volume, right? So let's put in the values and let's get the mass of the oil. So density is 0.9 and the volume is 144.44. So therefore the mass of oil is coming out to be 130 grams, right? That is option number A. Make sense?
Yeah.
Okay, good. Let's go on towards the next question. Question number 5. So this is just simple question over here. So we haven't started forces, but again you can answer this question simply, right? So a force is applied to a body, right? Which property cannot be changed by the force. So what is the answer for this question? Let's imagine you have an object here of mass m. You're applying a force here, right? So what property a force cannot change of an object?
It's mass.
It's mass, right?
Yeah.
So a force can change the size, right? Size, let's say if you have a spring, if you extend the spring by applying force, it can basically cause an extension, right? So the size of the spring can change. What about the velocity? If you apply a force, the speed of the object can change, right? So this is not the answer, and this is not the answer here, right? So you can also change the size here, right? You can also apply a force to change the shape of an object, right? But what can you not change by applying a force is basically the mass here, right? Because the mass is always conserved because of the law of conservation of energy. Sorry, mass. Make sense?
Yeah.
Okay, so let's do question number 6. Okay, so let's see what the question number 6 is saying here. Right? Question number 6 is saying that a boy stands on some bathroom scales right? The reading shows a mass of 50 kg. What is the mass of the object and what is the weight of the boy, right? Imagine for this question, you're using a value of gravitational field strength of 10, right? 10 Newton per kg. So obviously, when the scale shows 50 kg, that is the mass of the object here, right? So the mass of the object is 50 kg. So option C and D are wrong, right? So either the option number A is correct or B is correct, right? I want to find out the weight of the object, the boy here. So weight is equals to mg. So the weight is going to be mass, that is 50 times the gravitational field strength. So the weight of the ball is coming out to be 500 Newton, right? So the object has going to be have a mass of 50 kg and the weight of 500 Newtons. That is the answer. Option number B is your answer over here, right? Any questions?
No.
Okay, good. Let's go on towards the next question. Okay, so you have two identical beakers, right? Which contain the same mass of liquid. There is a beaker, there is a different liquid in each beaker, right? So we have different liquids, basically we are different liquids which have basically different densities here. But what is same of for both of the liquids? That is the mass that they contain, right? So the mass of the liquids are same here, right? So they are saying that let's say the liquid Q has density rho. So what will be the density for liquid P here, right? So let's first of all work out for liquid Q here, right? So what is the formula of density? Density is mass per unit volume here. So if you recall the formula of a cylinder, right? So obviously if you see this container here, the container is going to be shape of a cylinder, right? Right, and this is the height of the container which is given to you as 3h, and that is the, let's say, the radius over here, right? Because the beakers are same, we can assume that the radius of the beaker are going to be same, right? It's r. So how can you find the volume of a cylinder? Volume is pi r square h. So let's put in the value of the height of the beaker here. It's pi r square 3h. The volume is coming out to be 3 pi r square h, right? So let's place this value into the formula, right? So the density of the liquid P Q is coming out to be mass upon 3 pi r square h, right? So we can make mass subject since mass of the liquids in both the container are same, right? So let's see what happens now. So the mass of Q comes out to be 3 pi r square h rho, right? So since the question is saying that mass of liquid P is same as the mass of liquid Q, right? So we can equate the mass of Q to mass of P, right? That is going to be 3 pi r square h rho. So now we want to figure out that what is the mass of liquid P, right? So we can assume that it's again forming a cylinder of height h, right? So let's work out for liquid P now. The volume of the liquid P is coming out to be pi r square h simply. And let's find the density of liquid P now. So it's going to be the mass of liquid P divided by the volume, that is pi r square h, right? So let's make mass of P same, right? The subject over here. So it's going to be, this is going to go over there and multiply. So this is density of liquid P times pi r square h, right? So now you have mass P, right? And then you have this equation here, right? This is equation 1 and this is equation 2. We substitute equation number 2 in place of mass of P here, right? So let's do this now. Substituting 2 into 1, we get the following thing over here, that is density of liquid P times pi r square h is equals to 3 pi r square h times rho, right? So pi r square h cancels out. So the density of liquid P is 3 times the density of liquid Q, right? So your answer is option number C. Does that make sense?
Yeah.
Okay, good. So let's go on towards the next question. So I guess we have done this question number 8 in mass and weight. We can skip this. Let's do question number 9. Okay, so let's see what is the question number 9 saying here. Right, so you have doing experiment to find the density of stone. The stone is lowered into a measuring cylinder to fill with water, right? Which statement is correct? We have done this method multiple times. This method is called displacement method, right? So the difference, let's see option number A. The difference between the readings gives the density of the stone. That is wrong, right? It does not give you density, it gives you the volume, right? So let's see option number B. The difference between the readings give you the volume of stone. Yes, this is correct over here. Let's see option number C, just to make sure that we are correct, right? The final reading gives the density of stone. That is absolutely wrong, right? So option number C is not your answer. Let's see option number D. The final reading gives you the volume of stone. That is again wrong, right? The final reading gives you the volume of stone plus the liquid here, right? So the option number B is correct over here. That is the answer for question number 9. Make sense?
Yeah.
Okay, good. Let's go on towards question number 10. It's from mass and weight. Okay, let me check. Okay, so let's do question number 10 now. So a student produces some revision notes on gravity, mass, and weight. So which statement in his note is not correct, right? That you want to answer here. So let's check option by option, right? So which is your answer right now? A gravitational field strength is a region in which a mass experiences a gravitational force. Okay, this seems accurate enough. Let's check option number B. Gravitational field strength has unit Newton per kg. That is correct. That is not your answer, right? So you want the option that is not correct, right? Let's say option number C. Mass is a measure of amount of matter. Okay, that is correct. So that is not your answer here. So mass is equals to weight and multiplied by gravitational field strength. Right? So they're saying in option number D that mass is equals to weight times gravitational field strength. So that is incorrect here because weight is equals to mass times gravity, not the mass, right? So since it is not correct, and that is answer for question number 10 here. Does that make sense?
Yeah.
Okay. So let's do 11, which is a pretty simple question. I believe that you got this almost instantly, correct?
Yeah.
What is the answer for question number 11?
What B?
What?
B.
D.
B. B.
Okay, B.
Yeah.
So the question is saying that which property of a body resists change from state of rest or motion, right? So we talked about that this phenomena was called inertia, right? And which is what is inertia? Inertia is basically what? A property of mass, right? So wherever you see mass, that is the answer, by the way. So density is not correct, volume is not correct, weight is not correct here. So the answer is option number B. That is the mass, right? Make sense?
Yeah.
Okay, let's go on towards the next question. Okay, let's do it out. So yeah, what is the answer for this question? It's C, right? It is pretty simple here. This is all Newton meter. Newton meter is used to measure weight, not the mass. And this is beam balance here, right? And it is used to basically measure mass here, right? So that is option number C. Okay. Simple, straightforward question. So now this is a question on density. So what data are given over here? You given the density of gold, that is 19 gram per centimeter cube. Given that the gold is 2 millimeter thick and it has a cross sectional area of 4.5 centimeter square, right? So you can see that your density is giving gram per centimeter cube. That means that your volume should also be in centimeter cube, right? You want to find out the mass of the coin here, right? So you can imagine that it's a cylinder over here. You're given the cross sectional area and you're given the height, right? So you're given the area in centimeter square. That is correct. You want to convert the height, that is the thickness, into centimeters here, right? So what is the relation between centimeters and millimeters? What is 1 centimeter?
10 meters.
Yeah, it's 10 millimeter, right? So you can apply the ratio method to convert this into centimeters. So 2 millimeter is going to be x centimeter. So you can do six cross multiply. So your height in centimeter coming out to be 0.2 centimeters, right?
Yep.
Okay. So now you can simply find out the volume of a cylinder. So volume of cylinder is pi r square h, right? Or volume is simply basically cross sectional area into height, right? So you know the cross sectional area of the coin here, that is 4.5. You know the height now, that is 0.2. So you can find out the volume here, right? So it's going to be 4.5 into 0.2. That is going to be 0.9 centimeter cube. Now you can simply find out the mass of the coin. That density is equals to mass upon volume. Therefore, the mass is going to be density times volume. Right? So your mass is coming out to be what? That is density is 19. Your volume is 0.9. Units are matching over here. So you can simply multiply it out and get your answer. So it's coming out to be 17.1 grams.
Yep.
That is approximately 17 grams. That is the option number B is answer. Make sense?
Yep.
Okay, good. So let's go on towards the next question. That is, this question is from forces. So let's still do it out. It is simple. So this is stating that you have a block which is rolling down the slanted slope, right? You can imagine that this is the ground level surface, which is horizontal, right? And this is a slope through which your object is sliding down, right? So the question is asking that which arrow shows the direction of the gravitational force, right? So gravitational force is always acting downwards perpendicularly, right? So this is the gravitational field strength that is causing the weight component of the box here. And this is the direction where you have the gravitational field strength, right? So your answer is option number A. Make sense?
Yep.
Okay, good. So let's go on towards the next question. So let's see what is the question saying here. On Earth's surface, the gravitational field strength is 10 Newton per kg. So for this question, they have given you the gravitational field strength value. On Mars, the gravitational field strength is 3.8 Newton per kg, right? So a robot has a weight of 2000 Newton on Earth. What is the weight of the robot when it is taken to Mars, right? So let's see what is given to you. Given the gravitational field strength on Earth, that is 10 Newton per kg. They're given the gravitational field strength on Mars, that is 3.8 Newton per kg. They're given the object's weight on Earth, that is 2000 newtons. They're asking that what is the weight of the robot on Mars, right? So if we can find the mass of the object, the mass is going to remain same throughout the universe. So if you know the mass, we can simply find out the weight of the object on the Mars, right? So let's find the mass of the object. So we know the formula that weight of Earth is equals to mass of the robot times the gravitational field strength on Earth, right? So this is going to be 2000 is equals to m times 10, right? So your mass of the robot is coming out to be 200 kg. So the mass is going to remain same. So let's work out the weight of the robot on Mars. So it's going to be what? It's going to be 200 times 3.8. right? So therefore, the weight of the robot on Mars is 760 newtons, right? That is option number B. Any questions?
No.
Good. So let's do question number 16. It's from density. So given a cuboid here, right, which has the length 5 centimeter, breadth 4 centimeter, and height of 3 centimeters here, density of the block is 2.5 gram per centimeter cube. You want to find the mass of the block here, right? So it's very simple. It's a regular shape. You can find the volume of a regular shape, that is a cuboid SLBH, right? So just put in the values to get your volume 5 into 4 into 3. The volume of the cuboid is coming out to be 60 centimeter cube, right? You're given the density of the cube also, so you can find out the mass from the formula that density is equals to mass upon volume. Therefore, the mass of the cube is going to be density times the volume, right? So the mass is going to be 2.5 gram per centimeter cube times 60 centimeter cube, right?
Yeah.
Right. So the mass of the cube is coming out to be something in grams. That's 2.5 times 60. That is 150 grams. Make sense?
Yeah.
Okay, good, right? So let's go on towards the next question. That is question number 17. So what do you have in this question here? You have basically two blocks joined together, right? So one block has density of 6 gram per centimeter cube, right? And the other block has a density of 9 gram per centimeter cube, right? So this block has a density of 6 gram per centimeter cube. This block has a density of 9 gram per centimeter cube, right? So what is the overall density of the two blocks joined together, right? You cannot simply add them up, right? So you can see that dimensions are given over here. So it's a cuboid here. So it from here it is a square, right? So this is going to be 1 centimeter and this is also 1 centimeter here, right? So let me name this as A. Let me name this as B, right? So let's find the volume of block A first. You can see that the length of the block A is 1 centimeter, the breadth, the height is 1 centimeter, and the breadth is also 1 centimeter here, right? For the B, the length is 2 centimeter, the breadth is 1 centimeter, and the height is 1 centimeter here, right? So let's find the volume of object A, that is going to be LBH. So the volume of object A is coming out to be 1 times 1 times 1, that is 1 centimeter cube, right? So let's find the volume of object B. It's again a cuboid here. Let's LBH, right? So volume of block B is coming out to be 2 into 1 into 1, right? So volume of block B is coming out to be 2 centimeter cube, right? So I can now do what? I can find the individual masses also, right? So because I'm given the density of block A, I'm given the density of block B also, right? So let's find the individual masses of the blocks, right? The mass of block A is going to be density times density of A times the volume of A. So the mass of block A is coming out to be 6 into 1, right? That is 6 grams. And the mass of block B is coming out to be what? Density of block B times volume of block B. Therefore, the mass of block B is coming out to be 9 into 2, that is 18 grams, right? So now I can find the total mass of the combined blocks. The total mass of the combined blocks is coming out to be what? Is going to be mass of block A plus mass of block B, right? That is going to be 6 plus 18. That is going to be 24 grams, right? I can simply find the total volume also now by simply adding their volumes individually. That is volume of A plus volume of B. That is coming out to be 1 plus 2. That is 3 centimeter cube, right? Now I can find the combined density as follows. That combined density is equals to total mass of the blocks divided by the total volume which they occupy, right? So therefore, the density of the total object is coming out to be 24 divided by 3, right? That is 3 8 is 24. Therefore, the combined density of the block is 8 gram per centimeter cube. And that is the answer. Make sense? That is option number C.
Yeah.
Any questions?
No.
Okay, good. So let's go on towards the next question now. That is question number 18. A simple question indeed. Right, so you have electronic balance over here. You can see that it is measuring the mass of the object. The mass is coming out of 57 something over here, right? So they are saying that what is the unit of the reading on the electronic balance and what is the unit of weight, right? So if you use electronic balance, what does it calculate? Mass or weight,
Mass.
right? So it measures mass here, and mass is usually given in grams by the electronic balance. So option C and D are wrong. As the option number C is the answer, D is the answer. And how do we calculate weight? Obviously, weight is measured in newtons. So your option number B is the answer here. Any questions?
No.
Okay, good. Let's go on to our question number 19. Okay, so question number saying that which piece of apparatus may be used to compare the masses of the two pockets? Yes. So which instrument do we use in which we place the two objects to compare the masses and now get an idea that now they are same and therefore that is the weight of the mangoes or apples which I want to buy. Which instrument does that?
The balance.
Right? Is the balance over here. Manometer measures the gas pressure. So that is not your answer. Measuring cylinder measures volume. Micrometer measures length. So the answer is option number A. Right. So let's go on towards the next question. That is question number 20. Anji, so what is the question? What is question number 20's answer?
I got C.
Okay, why?
Oh, wait, is it? Um,
Why is it P?
it's like it's just like more thin, but it's still like as the height wise, it's still larger.
You should have a
The
logical
color.
reason for your answer, right? So let's read
Yeah.
the question. What is the question saying here? You have two cylinder measures that is measuring cylinders P and Q. They both are made up of copper, right? So if they are both are made up of copper, their density is going to be same, right? Or density of a single material is same, right? So they're saying that what else is given to us? That height of P is twice the height of Q, right? So let's say if the height of object Q is h, so the height of P is going to be what? 2h. And what else is given to you? That the diameter of P is half the diameter of Q here, right? So let you can now basically say that the diameter, if it is the diameter D for the Q here, so the diameter of P is D by 2, right? So which statement is correct if we are given this particular data, right? So before starting, let's see the question here. The question says that density is mass per unit volume, right? And what is the relation of density and mass? That density is proportional to mass and density is inversely proportional to volume, right? And how do you find the volume of a cylinder? That is from pi r square h, right? So you can also say that if the radius of this q is r, the radius of p is going to be what? Half, right? R by 2, right? So which statement is correct? So let's check it out step by step. Density of P is of cylinder P is 4 times the density of Q. Okay. So what is happening over here is what the thing which is happening here is, now let's try to relate the volume with radius and height. Right? Volume is proportional to height and volume is proportional to radius here, right? So we are going to compare cylinder P from Q, right? So cylinder P has twice the height of cylinder H, right? So if you increase the height, the volume is also going to increase, right? So if the height is 2h, the volume is going to be also twice times the actual value, right? Make sense? This is the first statement that we got here, right? The second statement which we got is that the radius of cylinder P is R and the radius of the cylinder P is basically half, right? That makes that if from the following statement we have a direct proportional relation, right? That if the radius goes down, the volume also goes down, right? So if you have reduced the radius by half, the volume will also reduce by half, right? So basically, the effect of doubling the height is canceling the increase in volume, right? So if you half the radius, the volume is decreasing by half, but that is compensated by increasing the height to twice the value, right? So the volume remains unchanged. Does that make sense? Does that make sense, Maeve? What
Yeah.
is happening here? Right. So from this relation, we basically see that the volume of P is going to be half time the volume of Q, right? But from this statement, we are getting that volume of P is going to be twice times the volume of Q, right? So the effect of decreasing an increment is basically getting cancelled out over here. So we can simply say that the volume is remaining constant and the mass is also constant, right? Therefore, the density of both the cubes is going to be same. Does that make sense?
Yeah.
Just to answer the option number C. So let's go on to what question number 21. So let's see what is the question number 21 saying to us. So the mass of object P is greater than the mass of object Q. The object contains different amount of matter and have a different resistance to change of motion. So which row is correct according to the data given to us? Right. So what is given to us that the mass of object P is greater than the mass of object Q here, right? So if you recall the property of mass, that the property of mass is inertia, right? And inertia is proportional to what amount of matter, right? So greater the amount of matter, the greater will be inertia, right? So from this particular data, what is your answer?
Let's see.
So which object has a greater mass, P or Q?
Mm.
P, right? So if P has greater mass, that means that it has greater amount of matter, right?
Yeah.
And that also means what? It has also greater inertia, right?
Yeah.
So which option is stating that answer?
A.
A.
If it's the
P has greater amount of matter, and if it has greater amount of matter, it's going to resist more change in motion, right? So this is basically just stating inertia, right? This column. That is option number A here. Make sense?
yeah.
Okay, good. So let's go on towards the next question. Okay, so we have, let's see, question number 22. Okay, it is simple. You can skip question number 22. Question number 23 is same. We can do question number 24. It is different. Okay, so what is question number 22, 24 saying over here, the last question? The diagram shows the equipment used to measure density of an object, right? So which equation is used to calculate the density of the liquid? So what is the formula of density, Maeve?
I got A. So
Right, it's mass
mass.
upon volume,
Yeah.
right?
Yeah.
So anything which is stating volume upon mass is incorrect. So this is incorrect, right? So either your answer is option number A or B, right? So you're finding the density of liquid. We had done the experiment in detail, right? So you can simply find the volume from the measuring cylinder, right? So option number A and B are saying that volume of liquid. How do you find the mass of liquid from experimentally? You basically,
By using
yeah, you basically measure the the mass of beaker plus liquid, and you basically measure the liquid only, right? And then you subtract the two things. So basically, you measure the mass of beaker plus liquid, and then you measure the mass of only empty beaker here, right? So this basically gives you the answer of mass of liquid here. So that is option number A. Mass of beaker and liquid minus mass of beaker divided by the volume of liquid. Okay.
yeah.
Okay, Dee, so let's now start quickly. Just do one question. I have another class in just few amount of minutes. So we are done with P1 now. Let's go on towards P2. So you had to solve question number one and question number four. So which question was difficult to solve? One or four? We can do one question right now.
Um, I think question number 4 was the
Okay,
easiest.
question number four. Let's do question number four. So let me just copy the scenario of the question. Let's copy the first part now. Copy the remaining question now. Alright, so you have this setup given to you in the question. So a figure one by one shows a jug of liquid and an empty measuring cylinder that is on an electronic balance, right? So the electronic balance uses the weight of the measuring cylinder to determine its mass. Weight and mass are different units. State two other ways in which weight differs from mass. Case Smith. What two other ways are there in which the mass and weight are different?
So the weight depends on the gravity pull and it's also a vector quantity.
Hmm, good, right? So let's start with the first question, part A. Right, we need to state two differences over here because it is of 2 marks. Right, so you have to be precise here, right? So we can simply
Yep.
say that weight is a vector quantity, whereas mass is a scalar quantity. Right? What other major difference does it have? That mass remains constant throughout the universe, whereas weight depends upon the gravitational field strength. You have to be precise and accurate in your answer, right? Want to explain everything in detail. Make sense?
Yeah.
Okay, so let's see what is the question number B saying here. Part B. Describe how to determine the density of the liquid using the apparatus shown in figure 1.1. It is just the entire experiment which we did, right? In the end of the lecture. I told you that everything comes in your exam. So it is a 4 mark. You have to write a complete 4 points here, right? So first of all, you will say that the density is basically mass upon volume. So you can find the volume. Volume can be discovered by pouring the liquid in the measuring cylinder and taking the reading. right? And then the third point is basically how would you find out the mass, right? So measure the mass of empty cylinder and then measure the mass of cylinder and liquid, right? The mass of the liquid can be discovered from the following formula, that you can subtract the mass of basically cylinder and liquid from the mass of cylinder, empty cylinder, right? Then you can simply apply the formula that the density of liquid is equals to mass of liquid divided by the volume of liquid, right? That's how you get 4 marks. Make sense?
Yeah.
Okay, so let's see the last question here. So it is a numerical here. So we are given the density of liquid, that is 780 kilogram per meter cube. You want to find out the volume if the liquid has a mass of 0.65 kg, right? Instead of 2 marks, you have to be precise and accurate in your working, right? So let's do part C now. So part C is what is given to us. Always write down the data what is given to you, right? So given the density of the liquid, that is 780 kilogram per meter cube. Given the mass of the liquid, that is 0.65 kg. You want to find out the volume here, right? It is a simple question here. So density is equals to mass upon volume. That gives you 1 mark. Now put in the values and get your answer. That's 780 equals to 0.65 divided by V. So your V is equals to 0.65 divided by 780. Therefore, your volume is equals to what? It is coming out to be 8.33, 0.833. Keep your answer in 3 SF. 0.833 exponent minus 3 meter cube. And that is your answer. Make sense?
Yeah.
Any question, Maeve?
No.
So that ends our lecture. How much was clear out of 10?
9.
Okay, good. So I'm going to see you inshallah tomorrow. Till then, good night. Bye bye.